Hello everybody, Sir Beaton here and welcome back to another mathematics past paper practice video. In this video we'll be looking at matrices, some matrices questions. So let's head straight into the questions. So this question says, the matrix A and B are given as A, the matrix A is negative 1, 0, 3, 2, and the matrix B would be negative 3, 2, 1, 1, 4, 6. Determine A inverse, the inverse of A. So we want to find the inverse of A. So to find the inverse of A, we know the inverse of A is equal to 1 over the determinant of A multiplied by the adjoint of A. So we need to find separately the determinant and then the adjoint. So let's find the determinant first of all. So the determinant is equal to, so we're dealing with A. So it's this multiplied by this. So it will be negative 1 multiplied by 2, subtract 0 multiplied by 3. So negative 1 multiplied by 2 would be a negative 2, subtract 0 multiplied by 3 would be 0. So the determinant here would be a negative 2. So the determinant of A would be a negative 2. The next thing we want to find is the adjoint. So the adjoint of A, we switch these two. So this would be 2, negative 1. And then we flip the signs of these two. So this would be 0 will remain 0, and 3 will become negative 3. So it's 1 over the determinant, which is negative 2, multiplied by the adjoint, which is 2, 0, negative 3, negative 1. So we do some scalar multiplication. So it's negative half multiplied by everything in the matrix. So this would be negative half times 2 would simply become 2 over negative 2. Negative half times 0 would be 0. Negative half times negative 3 would be negative 3 over negative 2. And negative half times negative 1 would be negative 1 over negative 2. And we can further simplify this to 2 over negative 2. That would simply be negative 1. 0 will always be 0. And these two negatives will cancel out, and we're left with 3 over 2. And these two negatives here will also cancel out, and we're left with 1 over 2. So hence, we can say the inverse of A is equal to negative 1, 0, 3 over 2, 1 over 2. So the next question says, we have the same set of matrix. So they want us to show that A inverse multiplied by A is equal to the identity matrix. So let's remind ourselves what A inverse is. So it's A inverse multiplied by A. So we know A inverse would be negative 1, 0, negative 1, 0, 3 over 2, and 1 over 2, multiplied by A, which is negative 1, 0, 3, 2. So let's do some multiplication. So it's row by column. So it's the top row by the column. So this will be negative 1 multiplied by negative 1 plus 0 multiplied by 3. I move on. Negative 1 multiplied by 0 plus 0 multiplied by 2. And then we move on to the bottom piece. So it's row by column again. So it's 3 over 2 multiplied by negative 1 plus 1 over 2 multiplied by 3. I move on to the next column. So it's 3 over 2 again multiplied by 0 plus 1 over 2 multiplied by 2. So you want to look at these numbers, they must correspond. That is a nice hint when you are multiplying matrices, especially 2 by 2. So, and then we do some simplification. So negative 1 times negative 1, that would be 1. Plus 0 times 3 would be 0. Let's work out this piece. Negative 1 times 0 would be 0. Plus 0 times 2 would be 0. Let's work out this piece now. 3 over 2 times negative 1 would be a negative 3 over 2. Plus 1 over 2 times 3 would be 3 over 2. Move on to this piece now. 3 over 2 times 0 would be 0 plus 1 over 2 times 2 would be 2 over 2. Hence, we can simplify this further to be, so 1 plus 0 would be 1. 0 plus 0 would be 0. Negative 3 over 2 plus 3 over 2, we know that would just give you 0. And 0 plus 2 over 2, so you know 2 over 2 is the same as 1. So 0 plus 1 would be 1. Hence, this is the identity matrix 1, 0, 0, 1. So hence, we therefore showed that the inverse of A times A would of course give us the identity matrix, and we have our 2 marks, and we are good to go. We're smiling in the exam. Now, with that, this has brought me to the end of this video, and of course, I want you to practice questions like these. Keep practicing the past paper questions in the past paper book, and I'll see you in the next video in which I'll be looking at another past paper question. Until then, keep practicing and take care.